All right, we're jumping to Chapter 9 because this material is on the CLEP test, on the college algebra test. There's no trig until you get to the pre-calc test. So we're going to wait on the trig, but after we get on Chapter 9, we'll go back to Chapters 4, 5, and 6, okay? All right, so here's the three things we're going to do today in Section 9.1. All right, use sequence notation to write the terms of the sequence. We can use factorial notation. And then we'll also write the expression of the nth term of a sequence. Those first three today, okay? All right, we got some terms to get through first, so I want you to write these down in the descriptions. A sequence. This is a function whose domain is the set of positive integers. Okay, not the range, but the domain. So that means our inputs. When we put in a number to these sequences, they're only going to be integers. All right, and this is quite often how they're represented. We say this is a sub n. This little n they put in the subscript is something that's common with sequence functions. N will mean the number of terms. So if we want to find the 10th term, we call n 10. So we do a10 and plug in 10 right there. First term, we do a1. Okay, you may have seen this a little bit in Algebra 2, I'm not sure. Okay, so the terms of a sequence, I was kind of just hitting at this a little bit. The terms are denoted this way. So if I put a little 1 in this little subscript, it means the first term. A2, A3, and then so on, ... Keeps going. Okay, so for example, if you want to find the first term of the sequence, I'm going to piggyback off this first example. I plug in 1 here and here, and I'd say A1 is 3. Okay, if you want to shorten this and not show all the work, fine. Maybe just show it for the first one. And then A2, well, what would that be? Well, 4 times 2. 8, take away 1. Okay, so that's how we'll find the terms of a sequence. Okay. I did note, sometimes they do start at 0, so if you see like an ace of 0, that happens sometimes, okay? 0th term. Okay, a couple more terms we need to go over. Okay, recursion formulas. These formulas are defined using previous terms, sometimes 1 or more, typically just 1. All right, so they're defined using previous terms, which will be given to you. You don't have to figure that out. And they're denoted this way. So if you see an ace of n plus 1 down here, that means the next term. If it's ace of n minus 1, it's the previous term. And you can use some numbers to substitute and think about it, right? If it was 10 plus 1, 10 plus 1 is the 11th term. That's the next term. This would be 10 minus 1. Previous. Pause at home if you need more time. Okay, the last concept we need to define is, last one's called factorial. So if n is a positive integer, then n factorial, bless you, is, they use an exclamation point for this. Okay, it doesn't mean you scream the number. It means something different in math. Okay, so in general, it's n, and then the next number down is what you multiply it by. And then the next number down, all the way down to 1. Okay. I did make mention here, 0 factorial is always 1. If you forget that, calculators are programmed to know that too. And I'll show you where the factorial button is in just a moment. Okay, so let's use a number here to demonstrate. So if you see 5 exclamation point, we're going to interpret that as 5 factorial in math. And that means we start with 5 and we multiply each number all the way down to 1. Okay? Now, obviously, it's not that long to punch in that product. But if it was a 15 or 16 factorial, that'd take a while, right? So there is a button for this. So let me show you where. I don't know if there's one on like a smartphone or anything, but graphing calculators are usually programmed with this. Okay. You got to punch in the number first. So let's just punch in 5. And then we want to find math on the left-hand side. Okay. And then it's under the probability feature right over here. So if I go here, you see it as the 4th one down. Okay, so if I hit that, 5 factorial is 120, which would be the same thing I'd get if I expanded out the multiplication. Okay. All right, let's go ahead and take a look at these first 2 examples. Write the first 5 terms of the sequence whose general term is given. And that's this first learning target. We can use sequence notation to write terms of a sequence. All right, so you got to remember that for these sequences, the domain is positive integers. That's what you're plugging in. So if I want to find the first 5 terms, we're going to start with ace of 1, like this. Okay, let me walk you through this one. So 1 goes in here to denote first term. And then I need to plug it in here where I see n, and then there where I see n. It's just evaluating a function. Okay, and that's it. Follow your order of operations. So work inside the parentheses first. So this 1 squared plus 1 is 2. This -1 to the first power is -1. We get -2. Okay, go on to the second one. Usually a pretty easy concept to understand. Just take some time to work through it. -1 squared is 1. Now I'm plugging in 2 for n at both those 2 spots to get 5. Keep it going. Okay, notice what's happening. This -1 to the n power, it's going to change the signs. So then I take -1, raise it to an odd power, becomes -1 again. Okay, so we see these signs alternating when that happens. Okay, 4th term. We're taking n squared, so now 4 squared 16, add 1 to get 17, and now we're back to a positive number. Okay, catch on to that pattern. So now A5 will be an odd one here, and then we've got 25 plus 1, -26. Okay. All right, number 2 involves a factorial. Let's have you take 30 seconds to try A1. And then I'll give you some feedback on that to make sure you did it right. And then I'll let you finish the rest of number 2 after I show you that. Okay, so pause and try A1. Okay, so plugging in 1. So again, just follow the parentheses. 2 factorial. And now you know what 2 factorial is. Do you really need to pick up the calculator to do that? Not if you know the definition, right? It's just 2 times 1. That's it. 2 factorial is 2. Okay, so once again, one more here, and then let you continue on, finish this one. So I'm throwing in n, which is 2 for the second term, here and here. So again, 3 factorial. Can you do that in your head? I hope so. 3 times 2 times 1. And then you just divide at the end to get 3. Okay, keep going. Okay, here's your feedback on the rest of it. All right, so focus on the parentheses. Factorial kind of is next. You want to multiply before you divide, so just do the top. Clean up the separate parts of the fraction before you divide. Okay? Okay, 3 and 4, I don't think we really need those right now. 4, we might just use as a warm-up tomorrow. But 3 is, we don't, just like 1 and 2. So let's skip that for now so we can get to the next learning target, okay? All right, so we're going to get into this recursive formula now. Definitions we talked about, I think the 3rd box down. Recursive, now they did change it to k, but they could also put n, any variable in here. Don't let that throw you off. But in any recursive sequence, they're going to give you the starting term. We start to 8. This just means the k plus 1 means the next term. So to get the next term, I take the previous term and take away 5. And once you get used to that, sometimes you can just roll with the pattern. But if you don't see the pattern, let me show you a way we can kind of work through the substitution. Okay? So to find A2, right, it says write the first 5 terms. Well, they gave us the first term, so they already gave us the first answer. We've got 4 more to find. Okay? So what's the next one? We got to find A2. Well, we want to let n, or k in this case, be 1. Go ahead and write that down. Let k or n equal 1. And what that does now is right here I'll have 1 plus 1, which is going to be a2. Okay, so all I'm doing on this first step is I'm just strictly putting 1 here and here. That's it. And that's a2. So now I have a way to find a2. I use a1, subtract 5. And a1 was given. So 8 minus 5 is 3. Okay. All right, and then we just repeat the process. So now I'm going to go on to a3 and do the same thing. Okay, so now I'm going to let k equal 2. Why did I do that? Well, I got to keep going up for 1. Or you just look at this. How do I get the third term? Well, 2 plus 1 is 3. Okay, so I got to let k equal 2 now. K is 2, then it would look like this. Okay, all right, so here we go. A3 will be equal to the previous term, a2 minus 5. So you'll start catching on the pattern. We're just taking the last term, subtracting 5 from it. Okay. All right, once you catch on the pattern, do you really need to keep showing all this work? Probably no, you don't. Okay, so I just kind of put a rolling list here, a rolling tally of the answers. A1 was given. To find the next term, we had to subtract 5 from it. And then we just kept subtracting 5. That's it. Okay. Usually once you have the first 3 terms, it's enough to establish the pattern. Okay, and you also get used to the fact of just 1 term minus 5, you can read this, and you can roll with that too. Okay, all right, see if you can, well, let me take you through 6 a little bit, get it going for you, and then let you maybe finish 7. Actually, 7's a little different. 6 is a lot like 5. So you guys try 6. Go ahead and get that going, and I'll give you feedback on 6 in just a moment. The quicker you get used to this notation, the easier it is to catch on to this. This just says the k plus 1 means next term. I don't care if this is the 10th term. So if this meant 10th, this is the 10 plus 1, 11th. To get the 11th, I need the 10th. That's all. Okay, so they've given us the first term. We're going to start off by finding the second term. Okay, so a2 will be equal to 1/3 of the previous term. So we get 12. Okay. Now if k equals 2, so that means it's 2 plus 1 or 3, and then this is a sub 2. So a3 equals 1/3 of a sub 2. So I just take that number now and throw it on down here. 1/3 of that is 4. Okay, once you get the pattern, keep taking 1/3 of everything. So 1/3 of 4 is 4/3, and then I multiply this by 1/3 again, right? So 4/9, 3 times 3, 1 times 4. And we're done. Okay, number A1 was given, so these are the next 4. Okay. All right, now 7 actually does give us 2 terms to start with, so it looks a little different. So let me help you get this one going. Now they give us a sub 0 and a sub 1. So we can find a sub 2 right now, because now would they put it in terms of subtraction, but just think about it. This is a2, so 2 minus 2 is 0, perfect. 2 minus 1 is 1, perfect. I've got those terms. Okay, so they're always going to ask you to use the previous terms they gave you over here. You just got to figure out what they're asking us to do here. So we're going to let k equal 2 right now. Like I said, just some common number sense. Look at it. What number would work? 2 minus 2 is 0. 2 minus 1 is 1. And now I can go ahead and use it. Okay, you might not need all these steps. I don't know. I'm just using this as a teaching tool. So if k equals 2, plug it in there and there. All right, and then just grab those numbers that they gave us. They said take a sub o, which is negative 2, plus 1/2 times a sub 1, which is 6. Okay, so those terms are going in here and here. All right, so negative 2 plus 3 is 1. try k equals 3. Go ahead and plug in 3 in these spots for k.